Hello everybody, I'm Carl Nicholson, the Chief Information Officer at Synaptech. We're a UK business, and as far as GalaxZ21 is concerned, we're sponsoring the event this year. We had such a great time, we thought we'd come back and play a bigger part this time around. So Synaptech as a company is an automation and integration business, and we are interested in redefining how things work. So in terms of business process, and we've applied this in this particular scenario that we're going to talk about today to the IT operations space. We started off very small and we've seen a massive growth over the last 12 months. We started life as IT operations people. That was our bread and butter. And we sort of saw an opportunity whereby infrastructure as code, the cloud, AI presented really interesting ways of getting our work done. So back in the day, we'd build our servers manually, sometimes even physically. We'd look after them, and that was what we did. That was our professions. But as the clouds accelerated and IT's become more complex, we realized there's a massive opportunity here using new technologies to get stuff done. So we created Synaptech, and we created Synaptech because we thought it presented an opportunity to change the way that IT operations is fundamentally delivered, but also how it's supported in terms of when things go wrong and how quickly we can react to that by using data and an AIOps approach. So in terms of us, as my marketing team tell me, we've got all the Asians here. We do consultation, implementation, and optimization. And what this really means is, as a company, we can help you link system A to system B, right the way through to your whole automation strategy, or even, you know, here's my golden view of the world that I'd like to have, please. That involves 25 data points across 25 different platforms. Can you help me knit that all together? And then just for fun, we can even throw in the hyper automation angle, and we can start to apply AI ML to those data points to enable us to ultimately get things done. And we're going to look at some specific examples as we move through this presentation. But first, for those of you who joined me last year, I'm sorry there's going to be a bit of repetition here. And for those of you who didn't, this will be new. But we're going to have a look at what Synaptech launched last year at GalaxZ, and it was called RoboNock and RoboNock version 1. So let's wind back the clock. So here we have it. We're doing this because we're going to talk later about what we've done with this in the last 12 months. The answer is a lot, and how we've built upon this foundation to deliver the future. So what did we do? We wanted to build a system that basically brought loads of different data points from across the IT estate to enable us to get things fixed faster. And obviously this is a network operations center example, and you can see here there's quite a lot of data there, and we're going to break down where this data comes from and how this helps us fix things. So without further ado, we started off with a collaboration hub, and in this particular example it's Slack. We like Slack, it's everywhere, it's ubiquitous, and it enables us to show a lot of information in one easily accessible place because it's on our phones, it's on a website, and it's on our desktops. So it's easy to get to. It doesn't matter where we are, we can see what's going on. So we start there. Then we take the data that Zenoss provides us, and we add that into the mix. We then take some Synaptech IP to try and understand this data. So we've got this data. Zenoss has told us something's broken. It's told us where it's broken. And we've gone and asked the particular device a bunch of questions in the background. So API communication between the multiple platforms to say, what are you? What is your function? What can you tell me about your current device state, et cetera, et cetera. And the whole point of this conversation between the devices is to enable us to make smart decisions on how we best fix whatever it is that's not working. So as it says here, the virtual server has stopped. However, the host machine is in good health. So what it means here, and it says at the bottom with the little Synaptech S there, is based on previous incidents of this type, we think the issue here is the virtual host, and therefore AIOps recommends the following actions. And it's proposed 3 things there: to run a diagnostic, to reboot the virtual machine, or to redeploy the virtual machine as well. What's behind all of this? And in this particular example, it's ServiceNow. So as you can see here, ITSM ticket number, we've got a ServiceNow ticket. So all of this data and all of this workflow between platforms to provide us data we're using ServiceNow as our logbook in effect. So we've created an incident, and all this information that appears in this ticket is already written to ServiceNow before anybody's even touched it. The buttons at the bottom, the doing bit, we've used Red Hat's Ansible product, actually Ansible Tower to be exact. That enables us to have some automation and orchestration capability right from the ticket. And last but not least, we've used a Twilio integration to send text messages, etc., to kick off a major incident. And we'll talk about that more later on. As we said last year, this is just an example. So we've taken platforms that exist at various companies, we've workflowed them together, we've used the data pipeline in the background to interrogate pieces of the infrastructure to find out what's going on to enable us to fix it faster. Okay, so let's fast forward to today. That was 12 months ago. And as I said, we've had an explosion of growth in the business in the last 12 months. And the team have been very hard at work to build upon that foundation, RoboNoc version 1, as we call it. And where could we take this? What else could we do with this technology? And we looked at that and we were pretty happy with it, to be honest, but you can always do more, you can always improve. So what we did is we took it up a level, basically. And we want to talk now all about observability. And what we mean by observability, for those who don't know, it's basically casting the data net as wide as possible to gain as much insight from across the estate to enable us to make intelligent decisions on how to get something fixed. And one of the things that we've seen in general is monitoring tools are great, but they only tell you in terms of thing is up or thing is down. And you kind of want to know more than that. So as it says here, it's complete visibility across the system. So the more data points you can hook in, the better. And a great example of this, because it took me a while to get my head around this, is sometimes things break because they do. Sometimes they break because of some third party in terms of an update, or someone's unplugged something or whatever. Or sometimes it can be as simple as a license has expired. Now your monitoring tool probably isn't going to tell you that a license has expired. So if you've got your licensing server or whatever looks after licenses in your estate hooked up to the system, and you add it to your sort of observability, wouldn't it be great that if something fails, we double check our license server to make sure it's licensed? Is it as simple as a license has expired? And I know that sounds ridiculous, but as someone who's worked in IT ops, many times I've been called out of bed because a license has expired. So that's just an example, but you get the idea. It's all about taking in data from as far reaching as possible across the organization to enable you to make better decisions ultimately. Again, so observability, monitoring, understanding what's working and what isn't. And in terms of strategy, I think it's important to remember to always measure what you care about. If you don't care about it, don't measure it. And the AIOps piece, which obviously melds these two pieces of data together. So you've got the monitoring, is it up, is it down, is it alive, is it happy? The additional information from the other systems, and the AIOps piece that helps to give you the context, to help you understand this data. Because data's no good if you can't make sense of it. You can get as much data in the world as you like, but trying to understand what's really going on is key here. And this is a really interesting stat, which I really like. So it says here, 85% of all incidents can be traced back to changes ready to things just break. And I think that's really fair. And that's come from Gartner. Isn't that just right? Happens all the time. 9 times out of 10, it's due to something additional, like a patch, like a power supply failing, etc. Very rarely does technology just decide to do its own thing. There's usually always an underlying reason, or at least 85% of the time. Which is why we're really excited to announce today at GalaxZ21 an international exclusive of our brand new system built on RoboNoc's version 1 technology, and we're calling it Qualia. For those of you that don't know, Qualia is the intrinsic qualities of experience. So what that means is it's a measure of experience. And if us as techies have a sole purpose in life in terms of support and what we do, it's to look after our user experience, because without that, we haven't got anything. Okay, we still need the infrastructure in the back end, but it's all about that user experience. Nobody cares what the back end looks like, so long as it functions and the experience is key. So we chose the name Qualia. So Qualia integrates more platforms than ever before that we've had at Synaptech, to cast our net wide, to get that observability and make the best possible decisions to get those issues fixed. ultimately meaning the mean time to resolution gets smaller. There's far more to it, or far more to this system than purely just data gathering. And I'm going to dive into some of the specifics of what Qualia actually does for us now. So the first thing we have here, and this sounds really obvious, and it's something that I've always found quite perplexing in the IT ops space. So we all understand the concept of a ticket. When something breaks, a ticket is created in our ITSM tool, and that's grand. And often we allow the engineers in those particular resolver groups to decide what ticket gets done first, other than some very basic prioritization in the background. So one of the things Qualia does for us, and one of the things we wanted to fix from day one, was we wanted to apply additional logic to ITSM tickets, like the ones we have in ServiceNow, for instance, that will automatically tell the engineer, based on a load of different metrics such as SLA, how complex it is, has the engineer got the right skill set, etc. And it's automatically going to decide which engineer it should give a specific ticket to get it fixed. So for instance, just because that guy's on call or that girl's on call, if there's a VMware expert who's available and online, I'm going to give them the ticket first, just as an example. And that sounds really basic, but that's massive in itself, and just the tip of the iceberg here. We do automated escalation, and coupled with that, self-healing remediation. So there's some very lovely words there. What do they really mean? So the system helps the service desk and the engineers decide what should be a major incident. You know, for instance, here's the symptom I'm reporting. It could be as simple as, you know, I can't log into my whatever web server, but actually the system's telling me that I've got some bigger fundamental issues here. My network's down, my subnet's disappeared, my router's exploded, you know, I can't connect out to that web service, etc. And it's automatically going to prompt the service desk analyst or the engineer that you've got a bigger problem here. It isn't just about the fact that somebody can't log in or somebody's printer doesn't work. Again, massive. And the faster you can understand the scale of your issue, the faster you can get it fixed. There we go, following on quite nicely. The other one, automatic major incident process. So if the system's decided that this is a big problem and it needs to be, you know, a P1 or highest level incident that needs to be raised, the system then triggers the major incident process for you. Again, saving those valuable seconds where humans are trying to understand, well, is this a major incident? Do I need to get the CIO out of bed, etc.? The system decides for us. We all know Zenoss is fantastic at complex environmental monitoring. As tech's got more complex, infrastructure's got more complex, it's become geodiverse, it's across multiple stacks, etc., etc., etc. Systems have to be scalable, and nothing frustrates me more than having to have multiple portals or windows into things I'm trying to look after, especially in that major incident scenario, because time is quite literally money. Every second counts. We put up some scary figures last year from Gartner, I seem to remember. So again, observability, use multiple tools, absolutely fine. Use the best tool you can possibly find to monitor that particular part of your stack, but make sure that data is fed into your system, make sure it's part of that strategy so that you can make intelligent decisions when something goes wrong. Yeah, we've touched on this already, better decision making. So analyze the data across the multiple systems to help you make better decisions. And that is the fundamental underlying principle of what we're trying to do. Give engineers as much data as possible to help them make the right decisions. Self-learning and continually evolving. Wow, doesn't that sound wonderful? I wish I was better at self-learning. But no, what we mean by this is every single major incident, every ticket is analyzed. And we look programmatically. So once our major incident is finished and we've closed it all down, you know, typically that would spin up a problem record, and that will become a problem manager's job to go and ask people questions as why did this happen, how do we respond, would we do anything different next time, etc., etc., etc. We still do all of that. We log it all and we tag it with all the data we have in the background. Long story short, it basically means we can have better insight into problems, and so that if it was to happen again, we can prompt the users in the system to say, last time this happened, here's what fixed it. Do you want to try that again? And obviously, the more data we have and the more times we have issues, we can get to the point, hopefully, one, where we can prevent it happening in the first place. But let's say we can't, we know that if this happens, we should run that automation. And even if we can only do that 10% of the time, we're still keeping the infrastructure alive and up and preserving that customer experience, and ultimately saving money and saving face when things go wrong. So even that 10% is massive. It's worth quite literally millions. Lower mean time to resolution, very topical, as we discussed. Time is money. You can't afford for your infrastructure to be down ever, frankly. We all know as engineers that that's often not possible, but if you can reduce it and make it as minimal as possible, that's what you've always got to strive for. True single pane of glass, everyone says this. There's nothing more frustrating than when there's a problem going on and you have to jump into a million different things to try and understand. The whole purpose of the system is to try and bring it all together so you can make decisions faster. And last but not least, it's optimizing the end user experience. That's what this is all about. No, like we say, nobody cares what's under the hood. It's all about that front end. And as we know in the tech industry, customer experience is always, the bar is always being raised. And if you're not doing it, your competitor will be. And it's only a matter of time before they overtake you. So we've always got to strive to deliver an outstanding customer experience because they are the people who buy our products, et cetera, et cetera. They're the people we should be looking after. So this all sounds grand, doesn't it? So I'm going to pop this up now. Here's a little screen grab of our user interface. And I appreciate this is pretty vague, and we're going to actually dive into a live demo shortly where we'll show you some of this stuff, because as Elon Musk says, everything works great on PowerPoint, and he's not wrong. So until you see a real demo, it's not real, and we'll jump into that shortly. But what you can see here is the engineer's view of the Qualia interface. And what we have on this page specifically is that automatic categorization of tickets from its multiple data sources. And actually, you can click into each of these tickets to see more information, but I've just popped that up there for now, just for interest, really. And what you can also see at the bottom of that screenshot is we've got a change. So in the IT world, some companies have a change process or change advisory board, where to get anything done, you have to ask the board, I want to change this thing at this time, and if it goes wrong, here's my plan, and that has to be approved. And again, all mapped into ServiceNow and presented in this nice view. So as we said, new levels of productivity. Yeah, it's going to make people's lives easier. And as us as engineers, making our lives easy is great because it means we can preserve and fix that customer experience issue we might have. So it reduces manual error-prone tasks. I am terrible at manual tasks because I get bored. And I guarantee if I have something to do and there's 5 of them, by probably number 3, I'll have lost interest or looked at a butterfly or something, and I'll start to get it wrong. So let's take that away from the human. I know I'm rubbish at that, and I'm sure there's other humans who are very good at that, but let the computers do this for us. Why should I have to spin up the major incident process? If we know what the process is, and we're able to teach it to a workflow tool or whatever, let's let the computers do the heavy lifting. And let us do what we're good at, which is thinking about stuff. Consistency and accuracy, yeah, back to my example there, I'm terrible. So if we know what the process is, let's get the computers to do it for us. But better still, the great thing about computers is once we've given them a process, they'll do the same process every single time, for good or for bad. So the other nice thing about this is if the process isn't right, we can fix it once and it becomes correct from that point forward. And the same applies to, you know, the workflows around actually getting things fixed, etc. Automating ticket categorization. So again, here, what we don't really want to do is have people calling us saying, hey, I've got this problem with a thing. My name's Carl. Here's my computer ID. I'm at home. Here's my mobile number. Shouldn't we just know? We're IT. We gave you the phone. We gave you the laptop. We should know all of this. So again, if we cast that net wide, we've got observability in place. Let's use these data points. We should know it's Carl. We should know what laptop he's got. And ultimately, wouldn't it be cool if we could just fix the thing before he even has to call us or she has to call us? Triggering automatic remediation and diagnostics. Again, similar thing. If we've got the data, let's go get the diagnostics. Let's get them before we even have to think about it. Before we get the engineer out of bed, let's go grab that information so we can present that to the engineer before they've even done anything. So we've already saved vital seconds.
And now we'd love to give you a live demonstration. Okay, so before we get underway, everything we're about to show you is pre-production and is subject to change. So building on the RoboNock technology that we demoed last year, we're going to take the same platforms again. We're going to use ServiceNow for ITSM, Zenoss for intelligent monitoring, Qualia for notifications, and Red Hat's Ansible for automation and orchestration. And what we wanted to do, building on top of last year's tech, was use that observability methodology coupled with AIOps and intelligent automation to get work done. So the first thing that's going to happen is we're going to receive a text message. Let's imagine we're not at our PCs and we're out in town or something. And you can see it says here, a major incident has been declared, firewall 01 is down, the time it was reported, but also we have some additional information. We've gone into Zenoss and queried the service information to tell us, for instance, this is part of a redundant pair, so what the real state of play is in regards to our IT estate. But we've also gone into ServiceNow and pulled out some knowledge base articles to suggest some fixes. And all of this has happened so far without any human interaction. Let's imagine we're now back at our desks. We can see that we've got the ticket here, and the first thing we're going to do is acknowledge it, just to say, yes, we've got this, we're here. You can also see at the top, there's a banner raised system-wide to tell us that there's a major incident, and we've got the ability to then automatically launch a Slack channel with all the relevant parties in for quick comms to diagnose whatever this problem might be. You can also see here that the Slack integration is written back into the body of the ticket, so it's easy for us to keep everybody updated as to what's going on. And remember, the ITSM behind this web interface is ServiceNow. The next thing that's going to happen is the engineer is going to click the diagnose button. Now, this would normally happen automatically, but for the purposes of this demo, we've put it in as a manual step, just so the whole thing isn't over too quickly, so we can actually talk through what's going on. And what you can see here is the system has checked the status of the device in Microsoft Azure and found out what the actual problem is and recommended steps to fix the issue. And obviously the Qualia system now knows what it needs to do to try and fix the problem. So we quite literally click the attempt fix button, which in the background is going to spin up an Ansible playbook that's going to take care of the recommended steps the system's just mentioned to us. And now that the page is refreshed, we can see that this particular incident has been downgraded to moderate because obviously our playbook has done something. And if we look here, what you can see is that the ticket's been downgraded to medium, and we're awaiting confirmation from Zenoss to tell us the service has been restored, and that we can see an automation job's taken place via the Azure API that's effectively soft rebooted the firewall in the cloud. We can now see our colleague respond to us in Slack to tell us he's really happy that this thing's getting fixed. And the last thing we're going to do is close down the ticket. Again, we've done this manually for the purposes of this demo because in the real world, this would happen automatically as soon as Zenoss told us that the service was now restored.
Here's a great quote. Observability and AIOps start with the very basic premise. Learn what happens within your systems and avoid extended outages. And a little bit of pub quiz knowledge for you here. This is exactly how the human body works. So for instance, the human body knows what normal looks like, and anything abnormal, it treats as a threat. And that's how our bodies deal with things like illness, COVID-19, etc. It knows what normal looks like, it analyzes normal, and anything off-piste, it tries to deal with. Very similar to how Darktrace works, actually, with its Dijkstra's algorithm, if anybody wants to Google that later on. And I think it's spot on. Let's know what normal looks like, and then use the data to highlight what's abnormal so we can do something about it. And that's the fundamental principle of our Qualia system as well. Thank you very much for listening. I'm Carl Nicholson. I'd like to take the opportunity to thank Zenoss for inviting us this year again. And also a massive thank you to Synaptics engineering team, who I know have had a Herculean effort on their hands in building us this system. So thank you.